Okay, cosine law. The cosine law differs from the sine law in that you can only use it one time, and that's when you have a situation when you know, say, this angle. Let's call this angle, let's call it 100, and we know that this side here is 5 and this side is 7. Well, all along I've told you with the sine law that you need opposite partners. And opposite partners would be an angle and its opposite side, an angle and its opposite side, or an angle and its opposite side. But as you can see in this situation, we have neither of those. We've got this angle, and let's say we're looking for x. We've got this angle and its opposite side, but we're missing an angle here to correspond with that side, and we're missing an angle here to correspond with that side. So in this case, when we don't have a couple of opposite partners, opposite pairs, we have to use the cosine law. Now the cosine law is used when you have an angle, let's just erase this, when you have an angle that is inscribed by, not inscribed, but connected between two other angles. You know, a side and an angle and the other side. So you've got two sides here, one here and one there, and in between them is the angle that you've been given. It's called an SAS triangle. When you know the side right here, let's do this in blue. When you know the side, you know the angle that's between that and the other side. So if you've got a side, an angle, and a side triangle, you're not going to have opposite partners, and you're not going to be able to use the sine law. So for this, we use the cosine law. And this is what we start looking for. Side angle, side triangles. Okay? So if you take a look here at this example, you'll notice that we've got a triangle where I've got an angle that is the vertex of two other sides that I know. I don't have opposite partners. This side 14.1 would correspond to that side. This 16 correspond would be the opposite partner to that. This 16.1 or 16.7 would correspond to that angle, and I don't know them. And let's say, for example, I'm solving x. Well, in this case, I would recognize that I've got a side. I've got a side there, and an angle in between. That is a side angle side triangle. And so I have to use the cosine law, which we'll talk about here right away. And the cosine law is a bit of a complicated formula. It's more complicated than the sine law. Sine law is pretty easy. Sine over A, or sine A over A equals sine B over B, etc. Well, this comes directly from A squared plus B squared equals C squared. This is a direct derivative of the Pythagorean theorem, which we won't get into as to how that works. Just it does. And this is the formula we're going to use. So all you have to be able to know is that this side here, the side you're looking for, in this case what's going to be called x, is always opposite of the angle that you're given. In this case, 109. So the A, the B, the C are arbitrary. They're just arbitrary values for a formula. You have to plug the numbers in. So that's really all you have to do in this particular case, is take these numbers and apply them into this formula properly. Okay? So in this case, we're looking for this side right here. This is the side we're looking for. Okay? Well, it's opposite the angle of 109. So in this case, I would put x squared, why am I doing that in yellow? X squared would equal, and now the B and the C doesn't matter. It's just one of these sides and the other side. So I'm going to put 14.1 squared. Let me redo this so I've got some room down here. Go x squared would equal 14.1 squared plus, and I'm just going to fill this in, plus 16.7 squared. Subtract all that. Subtract 2 times 14.1 times 16.7 times, and let's just move this over a little bit further so I got some room. Come on, get over here. Times the cosine of 109. Okay. So then all I have to do is plug these into the calculator. Now the only thing you got to watch for when you're doing this, that's an easy value to calculate, plus that is an easy value to calculate. What you need to do here with your calculator is subtract and then bracket all of this in. Make sure you bracket that whole bit in. So now you've got basically three numbers. That plus this whole thing. Okay? So if you do that properly, and I want you to try that right now, maybe hit pause on this and see what you get. You'll end up with x squared equals 631.02. All right? And then you would take the square root of that, and so you take the square root of both sides, and you'll get x equals 25.1. Now what you have to do is you have to figure out, is that a reasonable answer? Well, 25.1 is the biggest, it's the biggest side, or the longest side, which is reasonable because this would be the biggest angle in the triangle, and we know the bigger the angle, the bigger the opposite side. So that is our answer. So what you're going to do here is, if you haven't paused it, put those numbers in, put these numbers in here, and see if you come up with that. And if you haven't, it's just a bed mass issue, and then once you get that, it's a square root of 631 to get you 25.1. Okay, here's another example. I'm looking for x. So I've got, in this case, I've got a side and another side, and I've got the angle in between. So this again is a side angle side triangle. So whenever I have a side angle side triangle, I don't have those opposite partners, so I can't use the sine law. And you'll find that the sine law is way simpler than the cosine law. So we always use it when we can, but in this particular case, it's just not available. So again, what I do is I simply put in the values. I'm looking for this, x squared, so I'm going to put x squared equals, and again, these two numbers, doesn't matter if it's 8.2 or 5.9 in any order. So I'm just going to go 5.9 squared plus 8.2 squared, subtract 2 times 5.9 times 8.2 times the cosine of 47. All right? And so when I go and do that, again, I'm going to take that plus, I'm going to square it, so that plus this, and then I'm going to put subtract in my calculator. I'm going to put this whole thing in brackets. So my 2 times 5.9 times 8.2 times 47 cos, or if you've got a display calculator, cos 47. And when you work that all out, you'll get 36.06. That's what I got. Okay? Now, obviously, we're not done, so we take the square root of both to find x, and x gives us an answer of 6.0. All right? And so that is the value of that side. So this side right here would be 6.0, according to these numbers. And that's how you use the sine law, or sorry, the cosine law. There's another issue that we have to deal with the cosine law, and it is this. What if you have all the sides, but you don't know any of the angles? What if you have this situation right here? Okay. For example, if you had a triangle like so, and you knew this was 5, and this was 6, and this was 3, let's say, and you wanted to find out what that angle is. Okay, remembering that this symbol right here, theta, is used, it's just a Greek letter, it's the variable that's used to find angles. Well, what do you do there? Well, all we do when we're doing this is what we're trying to find is now this. That's what we're trying to find. So we're just going to use some basic math, some basic algebra, which I know you all love, and we're going to isolate that piece right there. So what the first thing I would do is I would take and I would subtract a squared from both sides. So I would get b squared plus c squared minus a squared. I'm going to stick it in there. Minus 2 times b times c times cosine of a. And then I would take and I would add this to both sides to bring it over here. So when I get that, I'm going to get just positive 2bc cosine of a equals b squared plus c squared minus a squared. Then what I'm going to do is I'm going to divide both sides by 2bc, because that will divide that out. So then I divide this by 2bc. And this becomes my formula. I'm going to get rid of this. There's the formula to find the angle. And all I've done is I've isolated the cosine of A simply by doing some simple algebra. So that cosine of A equals b squared plus c squared minus a squared divided by 2bc. And again, we just use these numbers. And all I have to remember is that that cosine of A represents that angle. So if that's A, then that means that's small a. And the only thing that's significant about that is that's the number that I subtract. The other two numbers, doesn't matter what order they go in, but this is the one you have to subtract. You're always subtracting the side that is opposite the angle you're looking for. So in the formula, you got three numbers here, and some people say, well, does it really matter which one that is? Oh, can't really do that. And the answer is yes, it does matter. You have to, when you're doing this, make sure that you're subtracting the proper number. And in this case, the number is going to be 6 because it's opposite the angle you're trying to find. Okay? So here's an example. I've got a triangle that is 4, 5, and 6. All right? So here's the formula. And you don't have to memorize this. You just have to know that this is the formula you use when you're trying to find an angle, cos of A. And so I simply put in the numbers. So I'm going to find this is the angle here. And A is just arbitrary. That's just what it's called. So I'm going to go cos of theta is going to equal b squared plus c squared. And again, it doesn't matter which one of these I use, as long as it's one of those two, because this one that I'm subtracting there has to be that guy, because it's opposite the angle I'm looking for. So I simply put in 5 squared plus 6 squared. And again, it doesn't matter. I could put those either way. 5 squared plus 6 squared, subtract 4 squared. Divided by 2 times 5 times 6. All right, and so when I do that work, I'm going to get, I'm going to get 25 plus 36 minus 16 over 60. Okay, which gives me, and here's the trick. Since we're looking for the cosine, we're going to use the second function button. Whoops. So the cosine to the -1. And then I'm going to put all of this in brackets. And that's what I'm going to do in my calculator. The only thing is, what I would do here, just to make sure this is correct, is I would do this. I would do 25 plus 36 minus 16. I would get an answer, hit equals, and then I would divide it by the total, which was 2 times 5 times 6, or in this case 60. And that'll give you, as long as your calculators are set to degrees, that'll give you a value of 41.4 degrees. So see, take a couple minutes here before you move on. See if you can manipulate these numbers right there to get this answer. Okay? Now, let's try one more. So here's a triangle, and this is the angle I'm looking for right here. There's the angle. So this right there, 2.9, is the one I'm subtracting, and you'll notice when you go across here, that's the one I am subtracting. Okay? So I'm using the formula, and here's the formula here. Cos of z, because that's the angle, is b squared plus c squared minus a squared over 2bc. All right? And the 2bc simply is c are there. And why are they there? Because they're adjacent to the angle. So the only one I care about is this one, which is the one I'm going to subtract. Okay? So here's my numbers. And again, if I was doing this, and I just did it, I would put that in brackets, and I would put that in brackets. So you'll get 2.6 squared plus 2.2 squared, subtract 2.9 squared. You might get an answer, might hit equals, get an answer, and then divide by, put this in brackets, and then multiply that out. And when you do the work here, you're going to get an answer of cos of 0 is 0.2115. Now, again, you can do this in two ways. You can do it this way to get this answer, and then hit cos to the -1, or the second function of cos, and that'll give you an answer of 77.8 degrees. Or you could do it all in one step and just go cos to the -1 right here, and that'll give you the answer. Okay, so there's really what the cosine law is about. It's about finding a side when you are given a side angle side situation, or when you have looking for an angle, in this case, when you've got all three sides. All right? So what we're going to do is, or what you're going to do, and I'm going to leave for you to do, is your textbooks. And in your textbooks page, I didn't even leave the page. Christmas. Okay? Give me a second here while I look this up. In your textbooks, we're going to do page, it's right here, 100 and, wow, there it is, 136. Sorry about that. We're going to do page 136. Numbers 1 to 14, and then in your work text, we're going to do page, and I did again, page 73, number 1 to 7. All right, and that's what we're looking for. And again, all you're looking for is a triangle when you know looking for the side when you've got, or looking for a side when you know a side, and an inside triangle. So this is an SAS triangle. Or when you know a side triangle, when you know that side, and that side, and you're looking for that angle. That's what this is all about, those two things. And you'll find in your textbook on page 136 the key ideas and what you need to know. And those are the only two things we need to know for this section. All right? So that's what I expect to have done for Tuesday, that along with the sine law stuff when I get back, or I guess Monday when I get back from the PA. My number, if you want to text me, you should have this. But my phone number is that. So make sure that if you're having trouble, give me a text, okay? And I'll get back to you. All right, good luck, and I'll talk to you later.